So here we have our heart model, and to review a few things, this would be our right atrium and the left atrium, the right ventricle and the left ventricle. So coming out of our right ventricle here would be the pulmonary trunk, and then the aorta, which is going underneath the pulmonary trunk there, and it's coming out of our left ventricle, the aorta there. And then this would be a human's superior vena cava entering back into the right atrium of the heart. So one of the things on the list, part of the external anatomy, second from the bottom, was the ligamentum arteriosum, and it's shown here in white. It's a remnant of the fetal circulatory system, and it connects the pulmonary trunk with the aorta. So just in white, that little blood vessel right there. And then finally, we'll talk about the valves. So if we open our heart up, again you can see the left ventricle, right ventricle, and then right atrium and left atrium. So on both sides of the heart, we have our atrioventricular valves, so the valves between the atria and the ventricles. On the right side is our right atrioventricular valve, also known as the tricuspid valve. And then on the left side is our left atrioventricular valve, also known as the bicuspid valve. Now, exiting out of the ventricles are the semilunar valves. So exiting out of the right ventricle and into the pulmonary trunk, we have this valve right here, the pulmonary semilunar valve. And then exiting out of the left ventricle into the aorta is the aortic semilunar valve. So you will be required to identify the valves on a model as opposed to the dissected cat heart. Now moving back to our cat, we'll deal with the pulmonary circulation. So that's an exchange between the lungs and the heart. And we've already discussed the pulmonary trunk. So that's this structure right here, exiting out of the right ventricle. And the pulmonary trunk, again, just because of everything going on here, it's going to be difficult to see, but the pulmonary trunk is going to branch off into two pulmonary arteries, a right and a left. And those are traveling to the lungs. And then the pulmonary veins are going to return from the lungs to the heart via the left atrium. So an important thing to make note of here is that in general, arteries are traveling away from the heart and they're carrying oxygenated blood. And in general, veins are returning to the heart and they're carrying deoxygenated blood. But the pulmonary circulation is an exception to this general rule. So our pulmonary arteries traveling from the heart to the lungs are carrying deoxygenated blood. And then gas exchange, all of that good stuff happens in the lungs. And the pulmonary veins will return to the heart carrying oxygenated blood. So the best place to identify the pulmonary arteries and veins is just right at the base of the lungs there. And unfortunately, you can't see very well on this cat because the latex doesn't appear to have been fully injected, so there's not really any distinguishable red or blue blood vessels. But were these to be colored blue, they would be the pulmonary arteries. And if they were colored red, they would be the pulmonary veins. And unfortunately, no better luck on this side. Okay, so that's something that you might want to keep straight in your mind, or hopefully you had a chance in class to look at that on your own cat. Finally, the systemic circulation. So that's going to deliver oxygenated blood from the heart to the majority of the muscles and tissues and parts of the body, and then return the deoxygenated blood back to the heart to be reoxygenated. So systemic circulation is between the heart and the rest of the body. First on our list is the aortic arch, which we did already discuss. So this structure right here, the aortic arch. And again, the thoracic aorta is this portion right here coming out of the heart, and that's going to branch into the brachiocephalic artery and then the left subclavian artery. Okay, and then after those branch points, the aorta is going to continue down right here. This is our abdominal aorta, and that's going to pass through the diaphragm and continue down to feed blood to the lower parts of the body. So returning back up to the top, we had our aortic arch, our brachiocephalic artery right there, and then our left subclavian. This is a little bit difficult to see, but the brachiocephalic artery is going to branch into 3 blood vessels. So these two are the right and left common carotid. So the right being on this side and the left on that side. Common carotid arteries, and those are going to travel up to the head. And then finally, this last branch, the side here, would be the right subclavian artery. So we could see we went from our brachiocephalic artery into our left and right common carotids, and then our right subclavian is traveling over here, and then at this point it was ripped. So it would have been the subclavian, the right subclavian artery, and at this point, right where it crosses through the ribs there, it's our right axillary artery, however you'd like to say it. So it goes from the subclavian into the axillary artery, and then as it's traveling down the top of the arm here, it's our brachial artery. And round about this point in the elbow, it's going to branch again into the radial and ulnar collateral arteries. So ideally, again, the ulnar should branch off first, and then the radial. The radial is going to supply the extensor muscles on the top of the hand, or in this case, the paw. So unfortunately, I don't have a good example to show you here, but in this part of the elbow there, you should ideally have seen a branch. Thumb side would have been the radial collateral artery, and then pinky side would have been the ulnar collateral artery.